All right, so my name is John Stamper. I'm an assistant professor at the Human-Computer Interaction Institute at Carnegie Mellon University. I also am the associate director of our Master's in Educational Technology and Applied Learning Science program called MEDALS, you may have heard of. Also have recently started a new master's program in human-centered data science that's out of our Language Technologies Institute as part of our Master's of Computational Data Science. So if you guys are interested in any of those type of resources, you can talk to me afterwards. Most of my research is based on educational technologies and how we can improve those technologies using data that we collect from them. About eight and a half years ago, I started with a tool called Datashop. Has anyone here heard of Datashop? A few people. So Datashop is currently the world's largest open repository of educational data at a transaction level. About 2 years ago, while looking for additional funding for Datashop, we created a ecosystem called LearnSphere, which actually Datashop is part of. And so today I'm going to talk to you about LearnSphere and Datashop and some of the tools that you can actually use. And hopefully we'll get into those tools and you guys can try a few things out and see how you can look for learning inside of educational data. So the real goal of what I want to do with these tools is how can we look for learning in educational technology systems. All right, so first, LearnSphere is a community software infrastructure that's really bringing together a bunch of existing data sources and with the hope of allowing people to do data analysis across these data sources. We've got a great team, including Carnegie Mellon, Massachusetts Institute of Technology, Stanford, and the University of Memphis. And we have a website at learnsphere.org, which I'll drill into later and really drill down into it. But what I want to really point out on this slide is what we did as part of LearnSphere is to bring together some existing resources. So we had Datashop, which is located at Carnegie Mellon. We also brought in MOOCDB. Has anyone heard of MOOCDB? That's a resource at MIT that they've developed to handle MOOC data. There's a tool called DataStage, which is a data export tool from Stanford that includes all of Stanford's Coursera data and edX data that you can get out, as well as DiscourseDB, which is Carolyn Rosé's collaborative learning tools that does a lot of analysis on discourse in the classroom as well as online discourse such as forums. In fact, Carolyn will be talking more about DiscourseDB today in her talk. And then we also, as part of the LearnSphere project, have created multiple deployable instances of these different repositories so people can have their own instance, which I'll talk about a little bit more in a few minutes. So why create this LearnSphere? Well, one of the things that we noticed, particularly I noticed while we were developing Datashop, is that we had a very specific data model that worked for a lot of different people, but it didn't work for everyone. And also, each kind of community was building a silo of data that really reflected the type of learning that they were tracking and what they wanted to do, largely at different timescales and different data types. So this really messy, let me see if I can deconstruct this messy diagram here. But what we have on the x-axis here is a bunch of different timescales, starting from like the millisecond level all the way to years and decades, and the type of data that different people are collecting and analyzing. On the y-axis there, we have different types of data types, starting from like the simplest of clicks and people typing into text fields to doing essays and discourse, and even affect data like sensor data. And all these are being brought together, but different people are using them kind of in their own field. So you can see Datashop in the circle here. It looks at things like intelligent tutors, like the cognitive tutors, online games. It gets into some of the MOOC data, but we're really interested on students solving problems. And one of the key things which I'll show you in Datashop is that we care about is correctness data. So we're looking for learning through people doing activities that we can grade correct and incorrect. While other people might be doing things such as essay data and how do we evaluate discourse and students speaking in the classroom or typing online in forums. That is sort of the realm of Discourse DB. And then of course we have MOOCs and the different types of peer grading and people watching videos, analyzing where people are fast forwarding videos, where are they coming back. And then we get into, maybe hard to see up here, but we have things like standardized tests, course schedules, people's course records in an LMS, so their grades on their courses, degrees, income levels over time, where we might be tracking this kind of data over many, many years and even decades. And so additionally, we're looking at a bunch of different psychological constructs. Certain people are in the cognitive fields looking at how the brain activity is working. Other people are worried about metacognition and whether students are help-seeking and those kind of psychological constructs, and even into social and emotional and motivational type of things. So how do we bring this all together and allow research to happen where we can interact between all these types of data? And that's the goal of LearnSphere. We want to be able to find discoveries that just cannot be found in one of these simple silos of data. We want to do it easily. And another goal is we don't just want to be able to share the data, we want to be able to share the analyses so people can replicate and show how they did the analyses, and other people can build on that. So as I mentioned as well, one of the issues we had when we were building Datashop is it was centrally located at Carnegie Mellon University, and different universities and particularly commercial companies said, look, we'd love to give you our data, but we're not allowed to put our data at CMU. And some of that was, I think, justifiable. All the data in Datashop is actually de-identified at the student level anyway, so it's really not that big a deal. But due to IRB constraints, if you're familiar with IRB in the United States, which is our Institutional Review Board, and other privacy concerns, people were just hesitant to give us their data. So what I said is, why don't we make a model that people can keep the data at their local site, install an instance of LearnSphere or Datashop or MOOCDB or whatever it be, but then the metadata comes back to the central LearnSphere, so people know that data exists. They can share that data. They can connect to the different researchers. So another key element of LearnSphere is to be able to remotely share this storage. And currently, we have this working with Datashop, and we have several instances of Datashop. We have the main one at CMU. We have one at Memphis. We have one at Stanford, and we have a couple of corporate ones up as well. If you guys, anyone interested in setting one up at NUS, we'd love to have more instances of these systems. In addition, like I said, to the data itself, we wanted to find a way that we could easily share the analytics behind the data. So as part of LearnSphere, we've created this tool which we've called Tigris, which is a workflow authoring environment that allows people to create or implement their analyses and share them with others. And we built it to where it is extremely flexible. It's sort of a wrapper around existing analyses that people have. And you can write these in pretty much anything. We currently have analyses that are written in Java, Python, R, Excel, C++. And you can take this existing analysis that you have, kind of formalize the inputs and the outputs, and put it out there. So we have this idea that there's three key types of objects in the LearnSphere analytics tool. We have these import objects, which are basically ways to get data in, and that might be as simple as reading a flat file. It may be attaching to an existing file in Datashop or MOOCDB. And then we have this concept of the analytics objects, which are the actual analytics that you run, which we can put a wrapper, like I said, around almost any language. And then we have this idea of visualization objects or reporting objects, which you're able to build and share kind of the way to show your data. I'll show you an example where we put out learning curves a little bit later. All right, so that's LearnSphere. Now to go back, I'm going to talk about a part of LearnSphere, which is Datashop, which predates the LearnSphere. I'll tell you real quick how we got the name for LearnSphere. So originally, I submitted a grant called the Next Generation Datashop that had these ideas of sharing the analysis tools and having this distributed model. And how many of you write grants here? A few people. All right, so when you write grants, this was to the National Science Foundation, and it got rejected as being too incremental. And so part of that, I think, was the name, calling it the Next Generation Datashop. So I went back and I looked at what got funded that year, and there was this geography database called the EarthCube that got funded. So I said, oh, I'm going to change it to be LearnSphere. Sort of as a joke. That was just sort of our name that we started with, but it actually it wound up sticking and catching on. And then the other thing we did is we went back and we said, well, they were saying that, you know, you're looking at the same types of data. And so at the time that the MOOC concept was really hot, so we brought in MIT. They had this MOOC DB, and we said, would you be part of LearnSphere? So I changed the name, made it about MOOCs, and yeah, it got funded for like $5 million. So that's how LearnSphere came about. But it's really built on this idea of Datashop, which Datashop came out of the Pittsburgh Science and Learning Center. When you guys heard of the Pittsburgh Science and Learning Center? Okay, just a few. So back about 15 years ago, the National Science Foundation in the United States made several really large investments of $25 million to start the Science of Learning Center. And Carnegie, Mellon, and the University of Pittsburgh were fortunate enough to get one called the Pittsburgh Science and Learning Center. That lasted for 5 years and then was funded for another $25 million for an additional 5 years. So essentially $50 million to do a lot of learning science research. And one key part of that was to build a repository of data for all of the studies that were done in the Pittsburgh Science and Learning Center to come in. That's how Datashop was born. It was originally envisioned to be this repository for research projects. But it's since grown. We're now getting lots of data from actual online courses. For example, all of the Carnegie Mellon Open Learning Initiative courses flow right into Datashop, as well as data coming from educational games and several of our partners like Carnegie Learning, which is an actual company that has about 600,000 student users every year. It supports a lot of different kinds of research. A lot of people use Datashop to do their primary analysis and share their data. It allows you to do some of the initial exploratory stuff and look at course data. And it's also great for the fields of educational data mining and learning analytics for people who want to do secondary analyses on data that's not theirs, but fits a certain data model. In addition, as a repository, it has a set of analysis and reporting tools. These, again, are focused on student interactions and particularly ones that have correctness information. So students doing problems where they're getting things tagged as correct and incorrect. It's really easy to get data in and out of Datashop, but for exporting, if you do not like the tools that we provide you in Datashop, you can just simply export a tab delimited file and get it into your favorite spreadsheet or statistical analysis package. In addition, we have web services. So if you actually build a tool and you want to use it, you can connect through web services as well. The web services in Datashop have been somewhat superseded by this whole workflow tool in LearnSphere. And I would much rather you use LearnSphere if you can to do your analyses. But if you have an existing tool that can consume data, there are web services available in Datashop. So as a repository, it allows for full data management. We have this concept of a data owner and a primary investigator. The idea of the primary investigator initially came from it's being built and using it as a platform for doing studies through the Pittsburgh Science and Learning Center. We then realized we were getting data that didn't have a primary investigator, so we created this idea of data owner. And you can have one or both of those. So some data just has a primary investigator, someone who brought in their data. Some of it is studies that were done with a corporate client, so we have a data owner and a primary investigator. Other is just data that has been given to Datashop that just has a data owner. We have a data model, which I'll talk about shortly, but in addition, if you have additional data that doesn't fit our data model, you can add it as a file attachment. You can also attach research papers. We have a way to put in citations, including a primary citation for that data set. So for people who are looking to get their work known and works cited, it's great for having this idea of primary citation. And if you have a very popular data set that's public, you can get a lot of citations through that. It's been great for me for that. You can make your data private or public. About 40% of the data sets in Datashop are public. The rest are private. That typically means you cannot get into the data set without requesting access, but we have a full facility in there to request access to the different data sets. So how much data is in there? Made this slide a couple days ago. Update it. We currently have almost 250 million individual student actions from about a little over 350,000 students, which is equating to about 675,000 hours of students sitting in front of a computer typing in information. So there's a lot of data out there, almost 1,500 individual data sets. You can see from a bunch of different domains, and I'm sure you can find something interesting that would appeal to you in Datashop. So originally, as I said, this came out of the Pittsburgh Science and Learning Center, which had this concept of Learn Labs, which included like algebra and French and English second language learning and genetics. And those were where a lot of the data came from. We also had CMU's large body of work in intelligent tutoring and adaptive learning. A lot of that data has come in, including the Carnegie learning tutors, as well as our cognitive tutor authoring tool, CTAT. We also have lots of data from online instruction, primarily from our own open learning initiative, but it'll take data from any kind of online instruction. And we also have a lot of data from several games and simulation projects. It's worth noting the data is very fine-grained. It's at a transaction level. The average time between transactions is about maybe 6 to 20 seconds, but an average about 10 seconds. So you're getting data pretty fine-grained level. And again, it's data where students are answering questions or clicking buttons and things that we can assess as being correct and incorrect. In addition, we have a web application that allows you to do things like learning curve analysis, performance profiling, looking at which particular questions are harder, easier. If the questions are tagged with skills, you can drill down to the skill level and see which skills are harder and easier. And we also have this KC model or knowledge component model builder, which allows you to tag things with skills and then build learning curves over skills over time. How many people in here are familiar with learning curves? Just a few. Okay, so I should probably talk a bit about what learning curves are. A bunch of different ways to get to Datashop. If you Google Datashop CMU, you'll come to it. I usually go through pslcdatashop.org. You can also go through several other linked pages at learnlab.org, as well as learnsphere.org to get to Datashop. Creating an account is easy. We used to maintain our own database of users and passwords. As we're moving to this more distributed domain, we decided we don't want to be in the business of collecting passwords. So we decided to choose and use Google login. and in common. I don't believe NUS is part of in common, you know? I don't think they are. So in common is a login that's used primarily by universities in the United States, although there are some international universities that are part of it. But for you guys, I think the easiest way to get in is using a Google ID. If you have a Gmail account, if you don't, just create one. And as I mentioned briefly, we have this idea of public data sets and private data sets. So initially, as soon as you log in, you have access to all the public data sets. To get access to the other data sets, you can request access using the access button, which I can show you. Let me go and see if I can log in here. All right. This one. Just go here and do it.
Just so you know, somehow there are actually 9 people watching you online, even though we haven't advertised it yet.
Very nice. Okay. So
with all the Google Hangouts stuff.
Yeah. So when you come to Datashop, this is what it looks like. Originally, I'm going to click on Login. As I mentioned, as kind of a old effect, we still have this username password that you can no longer use if we have it for legacy purposes. Otherwise, you can use your Google login right here, which is probably what most of you will do. And again, we have in common if you're from a university that is part of the in common framework. I'm going to click on here. It's going to take me to my CMU login. And then make me authenticate through here. All right. So this is what you look like. What it looks like when you've logged in. On the left-hand side, you can see there's this concept of My Datasets. When you first log in, you won't have anything under My Datasets, but you can go over to the public datasets and explore those. And you can see there's literally hundreds of datasets. We're working on a new feature to do better searching, but I usually just use Control F if I'm looking for a particular dataset that I have been using. There's also up at the top, once you start using a lot of datasets, it remembers the last ones that you used. Let me see if I can, here you can see these are the last ones that I've been using. And then we also have private data sets over here on the left. If I click on that link. And scroll over. You'll see this, if it's a shareable data set, it'll have a request access button that you can click on. And if I wanted access to that, I could just click on it. It'll create a message for you that'll email the PI and data owner, whichever exists, and you can put in a reason why you want to use it. Say, I'm doing research in this area, I wanted to use your data set. And they'll typically respond within a couple of days. If you don't get a response, you can always, and for any questions, if you come up to contact us here, there's an email address for Datashop help that you can always email, and this will always get responded to in like 24 hours. We cannot guarantee that we can make that contact for a particular data set, but we'll try our best. We know how to track down most of the people who own the data sets in Datashop. And let's see, let me go and find a good data set here. There's a couple of recommended ones up here. I'm going to go into this geometry area one. when you go into a typical data set, there'll be a listing of the properties of that data set, and it'll tell you some description that the person who loaded it put in. It'll also tell you how many students are in the data set, the number of steps, and then whether it has what we call knowledge component models, which I'll talk about here in just a second. There's 2 levels of tabs that allow you to get to the various learning tools, as well as within each tool there's some other things you can look at, which I'll talk about. We'll talk about learning curves here in a second. All right, so Datashop uses some terminology, and one of the things that's been made Datashop successful, but also something that has made it a little bit less usable for some types of data, is that we do have a very strict data model. So we have this idea of Datashop as transactions of students interacting with an intelligent tutor and educational technology. We're really interested in items where we can assess student learning, so things where students are answering a problem, things that we can tag as correct or incorrect. To that end, we have this idea of a problem, which is the student doing a multiple choice question or typing in on a prompt. A problem could have multiple steps. So a step is how they might answer part of a problem. So you can imagine with a math problem, say it's finding a common denominator, you might have a numerator step and a denominator step. So that would be a 2-step problem. And then we have this concept of a transaction. A transaction is where someone is attempting a particular step. So they're typing into the text box that could create a transaction. So you can imagine a situation where a student types in an incorrect number in a text box. That creates a transaction. They get a message back saying it was incorrect. They type in the correct answer. That's another transaction. Both of those transactions belong to a step, and that step belongs to a problem. Now imagine if you just have a multiple choice question, it could be a 1-to-1 problem with 1 step. So in that case, the problem might just have 1 step. And if the student answers correctly, there would be 1 transaction. I'll go through an example here shortly. An observation is a group of transactions that we group together for a particular step. So again, students working on one particular prompt or one particular question might be what we call an observation. An attempt is a single transaction towards a step. And an opportunity is where we say a student has a chance to demonstrate whether they've learned a particular knowledge component or particular skill on each step. And so an attempt create is usually at an opportunity. All right, so knowledge components are skills or concepts or facts. I originally used the term skill, and I still tend to use those interchangeably, although we actually changed to the term knowledge component because it was more agnostic and people didn't complain. Certain psychometricians and cognitive scientists often complain that some of the things that we model in Datashop are not what they would consider skills. But things like, I'll show a geometry area example here in a second. Some of the skills in there are like find circle area, find square area, find circle circumference, find perimeter. These are, I basically say a knowledge component is something that can be used to solve a task, such as a skill. And it's tagged at the step level. So an individual prompt or a question will be tagged with a knowledge component. That allows us to create a knowledge component model or a KC model. And a KC model is simply a mapping of all the steps in a particular set of instruction to these knowledge components or skills. So it's the skill mappings. So you have a list of all the steps and then all the associated skills with them. And that allows us to build learning curves. Let me go through an example. So here's an example of a cognitive tutor to teach scientific notation. And I'm going to bring up the part up here. And you can see that the columns here are multiplier, expanded power, base, and exponent. And then the individual names of the prompts are multiplier 1, expanded power 1, base 1, exponent 1. Then we have the second row, which is just the same thing with the 2, and then the third row, which is the same as the 3. So each one of those individual prompts is going to be a step. And depending how you log it, this may be one problem or this could be 3 problems. You might count each row as a separate problem. And again, that depends on how the person logs the data when they're coming in. So let me clear it out. And so the student enters 8. That creates a transaction. The student enters 8 in multiplier 1, and that's tied to the step multiplier 1. Then the student gets to the next prompt and asks for a hint. And they enter 10,000, which is incorrect. It's flagged red. They ask for another hint. It happens to be a dropout type of hint, so it tells them to enter the answer. They enter the answer. So there we have 4 transactions that were created. And those 4 transactions create one observation to the step expanded power 1. And they enter the correct answer into the next prompt. They enter an incorrect answer, quickly change it. And again, so these 2 transactions are tied to the one step exponent 1. Is everyone following what I'm saying? All right. So now I'm going to walk through it one more time, but I'm going to change it to the terminology. So we have this triple that we use called selection, action, input. And then it's going to have the step name, the knowledge component, and the student's opportunity. So selection is what are they touching in the interface? What is the piece of, if you do any kind of coding, that would be like the name of the text box or the drop down or the button they might press. The action is what they're doing. So it might be entering text, it might be clicking a button, and the input is what they're typing in. So I'm going to walk through that same example. I'm going to do it a little quicker here, but student enters 8. Again, that's on the selection multiplier 1. The action is update text field, and the input they put in is 8. The step is called multiplier 1. The KC, or the knowledge component they're doing, we're calling multiplier, and this is their first opportunity to do that skill. They ask for the hint button. You see the action in that case is button pressed, and it just fills in the input as hint request. Go through. Remember, there were 4 transactions that become that one. Second. Okay, so that's their first opportunity for these 4 KCs, being multiplier, exponent, power, base, exponent. Now I'm going to go through, and let's assume this is student 1, and we're going to go through the second row, which is called multiplier 2. They go in, they enter 8, that's correct. You see it's creating the second opportunity for each of those on the second row. All right, does that make sense? Is everyone following kind of how the data is? It's really important to kind of understand this whole step versus transaction. And so that gives us different opportunities in the C skills, which we can turn into learning curves. And so a learning curve is just looking at the learning over time. So we do, in Datashop, we have a learning curve where the y-axis is error rate and the x-axis is the opportunity. So a good learning curve in this case, we'd like to see the error rate smoothly go down over time, which is analogous with the power law of learning. Sometimes you'll see learning curves that go up. So they're actually looking at correctness rate as opposed to error rate, which we use. So sometimes you'll see learning curves go sort of that way. It's sort of the opposite of this. We've just chosen to do errors. Let me jump into Datashop and I'll show you an example. So I've chosen a model called textbook, which is the one that was originally done with this. And you can see here's an example of a learning curve. In this case, the red data is the actual student data. The blue is a predicted model that we fit called the additive factors model. It allows us to do prediction. In this learning curve looks pretty good. You know, it's going down in a good rate, and it gets a little bit, you'll notice it gets a little bit choppy out here on the end. Well, that's because this is actually from an adaptive intelligent tutor. So students are actually dropping out as they're learning the skills. So by the time we get out here, there's probably just a few students left. And we can quickly look at this with this opportunity count table that we have down here. And you can see for opportunity number 1, we have 438 students. Opportunity number 2, it drops to 412. And by the time we're getting out to like opportunity 25, we're down to like 30 students. So those are typically students who have not learned the stuff yet. And by the time we're out into those where it starts getting really choppy, we're down to less than 10 students. So up at like opportunity 32 here, we got only 10 students left. So overall, this learning curve looks pretty good. And this, the skill model that this is based on, let me turn off the categorization real quick here, has a bunch of individual skills. So what we see up here is an average of all the skills. And if I go down, back out a little bit, you can see what those skills are. Things like circle area, circle circumference, pentagon area, trapezoid area. And you can see in this case, this is a very small data set. I use it because it's a little bit quicker when I'm demoing. It's about 50 students and about 3,000 transactions. Many of our data sets will have hundreds of students and hundreds of thousand transactions. And the more students you get, if it's a good model that you're fitting to, you should see really smooth curves. And you can see the all selected ones, which we see up here, is pretty smooth. But when we drill down into the individual ones, it gets a little less smooth. And maybe seeing a little less learning happening, like this circle diameter one. You can see in this case, it's not going down as well as we'd like. But again, it's probably an opportunity to see what's going on in this curve, which I'll show you in a second how we might do that. Let me go back. I was looking at the error rate. You can actually hover over that error rate and change it to look at other things, including the number of hints, the number of incorrects, or the step duration. So you can do a time analysis as well. Let's see, you can also drill down on individual steps and see which questions the students were answering on that particular step, which can allow us to do some analysis. So if we see like a spike in a learning curve and we say, what's happening there? Why are so many students getting that wrong when it looked like it was going down smoothly? We can drill down and see what is happening. Here's the example of drilling down on the KCs or the problems in the steps. I'll walk through another example. Again, we can also look for time. So again, here you see that this is looking at the time as opposed to the correctness information. And again, we get this choppiness at the end because there's so few students at the end there. We also have then the ability to change the data model. So the KC model, or the mapping of the steps to the individual knowledge components or skills. And we can do this really easily by exporting it out, editing in a tool like Excel, and then importing it back in. And we can see if the model that we have gets a better fit. And I'll walk through an example of that and give you guys an opportunity to do it as well. So what we want to see is the KC model creates a learning curve. So here's that data set that I was just looking at. And so this is a geometry area unit. We could say that every step in that particular unit is teaching a skill called geometry. And that would be acceptable, but would it show learning? it wouldn't. This is the curve we get when we tag everything as a single skill geometry. You can see there's no way you can see anything happening in there. And so we don't see smooth learning at all. So now when I switch to this KC model that has 12 skills, like circle area, circle circumference, we get this smooth kind of curve, which actually looks kind of nice. And again, there's the rise in error over there because it's an adaptive system, so students are dropping out. At the end, you're getting fewer students who don't know the still. So we could say, is this a correct or the best model that's out there? And let me go in and go back and so what do you guys think? This is a pretty good model. What we can do is we can look at the types of learning curves down here. And again, we want to see these be smooth and go down kind of smoothly. There's this composed by addition one is a particular problematic looking one. It's the flat learning curve that's kind of choppy. So composed by addition is where students are finding the area of a composite shape, such as maybe finding the area of the side of a house where it's composed of a square and a triangle. And so we might ask ourselves, so if this is students learning, we'd like to see this curve be smoother. So what's different about this particular point and this particular point right here? Why does it look like students are learning on these 4 or 5 opportunities, but then suddenly they get a high error rate here? And so we can actually drill down and look at the problems that students are working on a particular point. And again, this is adaptive instruction, so students are getting different problems every time. But we can see over here, we can see how many observations are on which problems. And so most of the students on this particular step are getting this watering veggies problem, which has about 16 observations and about 12.5% error rate. So that's most of the error. There's also this trogs problem. And for many of our data sets, we can actually, if you hover over this, you can actually see what that problem looks like in the system. In this case, this is a really old data set, so we just have it attached to a PDF out there, but you can see this is what that watering veggies problem. So it has a sprinkler and it's looking for the circle with, it has a square in it. So what part of the garden isn't getting done, getting watered? And so we actually did this and we said, you know, what's different about that problem? And then if we go in and look at this problem up here, you can see most are doing this POGS problem, 17 students with a pretty high error rate. So we can look and say, what's going on here? And again, very similar problem. You're cutting a circle out of a square in this POGS problem. It's a metal, you're cutting out a piece of metal. But what we found is in this first problem over here, it tells them you have a square and a circle and you need to find the composite shape. In this one, it's not really telling them that it's a square and a circle and that they have to use that composition. So it's like in the first problem, it's saying find the area of the side of the house that's a square and a triangle. In the second problem, it's just saying find the area of the side of the house. So what we hypothesized is there's this additional skill out there called that you have to know that you have to use these composite shapes. So what we can do is we can go into the KC models and we can export the one that we had. In this case, it was called textbook. And exporting, that's going to give me a tab delimited text file, again, of all the student steps that the students saw and the mapping for this particular model. So in this case, it'll be mapped to things like we saw circle, circumference, and we'd be really interested in looking at those ones that were specific to the composed by addition. So we could actually sort that then in Excel, look at composed by addition, find the ones that are the POGS problem, and add this additional skill to it called decompose or something like that. going to cancel this. I think it's taking a long time because I've actually already done this. And you can see somewhere in here is this model which we created decomposed, and we added this decompose step where we actually mapped it and re-imported it in. And in this list here, you can see we get, it actually lists, evaluates all the different models using root mean squared error, either student stratified or item stratified. And we also use AIC and BIC, Akaki information criterion, Bayesian information criterion, which are simply model evaluation items. And that allows us to see if our new model gets a better fit. And in the case of that decomposed to the textbook, we did get a better fit. So that kind of tells us that on this existing data, that adding that new skill probably will improve this instruction. At my talk tomorrow, I'll actually talk about a study we did where we actually did do that improvement and created some new activities and new things to isolate that new skill. And we ran a study, and we did actually see significant improvement in the course design by doing that. But this is a way quickly you can find what is the right granularity, what is the level of skills that you should be tracking things at. So for example, are finding square area and rectangular area a different skill, or is that the same skill? What do you guys think? Different? I mean, I think it's different. I mean, I think it's the same. I mean, I think it depends. It turns out we've looked at things like this, and it does depend. So when students are first starting out in geometry, it might be necessary to split out finding square area from finding rectangle area, so until they learn that concept. But it actually turns out that if you merge all of the finding area skills after they've learned it, it's really just a sort of a plugging numbers into an equation kind of skill. So things like parallelogram area, square area, and trapezoid area, triangle area, those all kind of merge into one skill after students have learned it over time. So it really depends on when you're teaching them. And by merging those in the later ones, you can actually get improved performance because you're not reteaching them the skill they already know. For example, let me go in and look at the learning curves on a skill over here.
So John,
yeah.
The question, students struggle with the question sometimes. It's not because they not been presented the correct knowledge in the past or necessary, but maybe a problem with the question.
It could be, and yeah, so sometimes, so I showed an example where we had a problem with our skill model, but often, yeah, you can find there'll be a big jump, like this little blip, and it'll turn out that the question is either incorrectly tagged, or it may just be a bad question, it's really badly worded. And those are the easy ones to find. Yeah, you can go in and you can fix that.
And you see that those blips.
Yeah, you can say, oh, yeah, let's figure out what's going on here. And yeah, ideally, if it's that's actually a great thing if we find bad questions, because those are easy to fix, right? We can just make a better question or throw the question out. Yeah, it's more difficult when it gets into these really of the modeling of skills, because what we'd like to see is every opportunity to show you have knowledge of a particular skill, we'd like those to be equal. In reality, we know they're not, especially in things like online learning, where you may only have 3 opportunities to show a particular skill. And typically those opportunities get harder. It starts with an easy problem, goes to a harder problem. So hopefully you would have the harder problems that really have other skills you're trying to teach as well, and you're accounting for that. Sometimes it's really hard to do that. Yeah, let's look at another skill down here. Let's see, square area. What do you guys think of this skill one? You can see out here, this little blip again is, if we look at the data by like opportunity 17, we only got 1 student left. We can actually cut that off too by, on the left here, you can actually have a max and a min cutoff. So if I say, you know, the max we want to look at is 17, we can cut off that bad blip. But what do you guys think? Is this a good learning curve? Smooth. it's really flat. There's a really low error rate, so that's good, right? But this is actually another opportunity for proving the optimality of a system really quick. What I can see really quickly right here is students coming in here really know square area, and we're giving them way too many square area problems. So we're really wasting their time on skills they already know. So in the case of this particular system, which is adaptive, so it has some model driving it, we have the parameters set really incorrectly, that we're giving these students too many square area problems. So that's,
should have dropped them out.
Yeah, they should drop out really quickly. And yeah, we may, realistically, we should only see 8 or 9 opportunities over here, and that should be the end of it. But for some reason, we're giving them more and more. And you know, when in a live system, there's some things that might happen that maybe other problems that have other skill also are requiring students to do square area. So that may be the case. But we could go back, and instead of making them do the square area, if they already know it, just give them the answer to the square area part. Don't make them do it again. You're wasting their time. So again, very, very easy way to improve a system quickly. We added this new feature called categorize curves, which I unchecked. I'm going to check it back, and it automatically will do some of this analysis for you by putting the knowledge components into categories that we said. So low and flat is a category that we say, again, we're probably giving students too many opportunities. Then we have this no learning category where you have kind of a flat slope, a 0 slope. So it's going back. It actually put square area into that category instead of low and flat. We have what we call still high, meaning the error rate is still high at the end. Students aren't getting this. And you'll typically see this in a lot of really hard problems. So in this case, trapezoid area for this set of students is probably the hardest skill. And then you see the learning curves that it tags are good. And there's no magic right now to these parameters that are set. The parameters that are doing that are right here on the left. We say how many students there have to be, how many opportunities there have to be, what the low error rate threshold is, what the high. So for different domains, this might change. You know, in math, in this data set, this kind of works. And these are parameters that we default to because we think they kind of work. But in other things, like some of the chemistry ones, you tend to have higher error rates at the end. You know, most students aren't getting A's, unfortunately. So you might need to change these, and it'll automatically categorize the curves for you. Yeah, so there's a tremendous opportunity to look at the different data sets that are out there for this kind of stuff. And we're doing that in our Open Learning Initiative courses. Let me see if I can find a good OLI course. So like our engineering statics is one of these examples where it's an online course. When the professor first reached out and came to us and said, you know, I really want to improve my course. I want to make it work on the knowledge components. This was one of the ones where he had way too few problems per skill. And we basically said, look, you know, to create a curve, we need at least 3 opportunities. So some of these questions that you only have two opportunities to show the skill, we need to create more content. So that's one of the things Paul Stife is the engineering professor we've been working with. But let me go into the learning curves.
Is anyone doing learning curves on courses other than STEM courses?
Certainly languages. There's a lot of language data out here. So, you know, it's definitely hard to do philosophy and things like that. We have some logic out there, which again might be more STEM-y anyway. But the things that works really well in our domains like math, like some of the STEM fields work really well. We have some good chemistry data out there, physics data. We have but a lot of language. It turns out language works really well. So we have a lot of French data. We have a lot of English as a second language data. I think there's some other languages. There's some Chinese out there as well. And those tend to also be really good candidates for this kind of analysis and this kind of work. Let me choose this.
Do you have Duolingo data?
We've been talking to them. I don't know if any of it's public, but if you're really interested in Duolingo data, we can get it. right down the street from us. And they have been doing some of this analysis, I know, on their data as well to improve their course offerings. Yeah.
Do you use any of this information to tell why a particular student isn't meeting the learning curve, or isn't learning over time, like looking at their individual transactions?
You can. So this is really the learning curve stuff that we're doing. So to build learning curves, it's on a set of students. We're averaging on students. There are some other reports like the error report where you can look at individual students and see what their problems are. And it'll definitely give you the predictive, you can export the predictive values of what a student knows, and you can look into those skills that they're not getting. And that can be a way to help you get started. The model that we use for knowledge components assumes that knowledge components are independent, which we know is not really true. They build on each other, but it can give you a good start. And there are other tools out there in the LearnSphere, which I'll show, where people are doing things like hierarchical knowledge components and things like that. But here's the statics course. And again, this doesn't look like a terrible learning curve. I'm assuming that by the time we get out to, yeah, like 0.11, we're kind of done here. But this is something that might be typical, again, of an online course where you might still have some choppiness at the end because problems do get harder at the end. And we can look at the individual components. These are likely tagged to units in the problems. I don't know how he's tagging this model, but there's probably other models in here. Yeah, here's one at the learning objectives. So typically what I'll do with the people who are doing online courses, we might create a model based on their learning objectives. So I'll just say, hey, tag all your learning objectives that make those skills or KCs and tag it to the individual problems. And again, you can see this looks okay, but typically it's too high of a granularity. The learning objectives typically break down into smaller skills that we want to see. But it's a good starting point, and I can look at the individual curves down here and say, you know, this one is showing no learning. So I can say, you know, why is this one harder than this one? Why is this one harder? You know, maybe there's another curve right here in the outset. This kind of looks like it might be a curve. So we could say, you know, is that a separate skill you're really teaching in this learning objective compared to this first area might be its own curve as well. So there might be 2 skills in there, or maybe 3 skills or 4 skills in that one learning objective. But this is a good way to get faculty started and looking at the data at this level and thinking about how, you know, again, I'm a very big believer in assessing while you teach. So making sure you have enough opportunities to collect data to see if the learning is actually happening in the course. I get some pushback from some people saying, you know, aren't you taking out creativity? And yeah, in some ways, yeah. So I had a big discussion with one of our computer science professors who wants to make the course more fun and more creative. And you know, so he thinks that making the opportunities so constrained takes away some of that. And I would agree to a large extent. And it's kind of what you want to hit some median maybe to where it can be fun, but you, again, if you're trying to optimize and track learning, you need to have these kind of opportunities that we can assess. Any questions on this so far? You guys think you can use it? Try it.
Is the data on this from strictly online courses?
It's strictly online educational technologies. Again, it's a wide variety of things such as online courses, intelligent tutorings in a K-12 environment. There's some games and simulations out here. But yeah, all of this data in Datashop is strictly educational technologies that have been collected at transactions online. Under the public data sets, I recently, last week, let's see, trying to find the, I was going to have you, do you guys all, does anyone want to try this? You guys have your computers or have access? If you want to try, there's an example data set I'm trying to.
Especially if anyone in the US who happens to have a computer, interesting can try it out. And I'm especially interested because people here in the US know the data sets better than I do. How could we actually, like, if we in 2 minutes from now, once you could ideally take a data show, how would that work? What would that look like?
So under the files out here in this geometry area one, if you click on files, there's a data exploration exercise you can do that'll walk you through some things you can do. So if you want to do this later, I encourage you. But it'll have you do things like look at the learning curves. I'm going to go in and see if I can do an export real quick of the KC model. So if you click on KC models, and you'll see this one has been used a lot. Typically, you won't see this many models in here, and this is because I use this one a lot for demos, as well as it's had a lot of research on it. But these ones that start with LFA as some of the first numbers, that stands for learning factors analysis. Those were all machine-generated models where we went out and we combined and tried to take the existing models that were out there and improve them by merging different components and splitting on different components. And you can see our best fitting models have come from this process often. And you'll see a lot of data sets out there that'll have these LFA models because we just ran it on all the public data sets that we had. Now, when you do this, it's a lot harder to interpret what these skills are. So when you're merging and splitting, and sometimes you get things that don't make sense, sometimes you'll find things that do make sense. And this is, in this process, we did find things like merging square and rectangle area actually give you some improvement, and it automatically does that. Let me see if I can export quickly. But you'll see things like the circle collapse, that's collapsing the different circle skills into one single skill. All right, so this opened up. Let me see if I can open this in Excel. Do I have Excel on here? Yep. If I can find that. Can you help me find that file, or I can save it again?
Does anyone have any ideas for like how you'd actually apply this to ideally data?
And now let me save it.
Can you not get the average? Can you pull out individuals, like outliers, like people who are not beating the learning curve, like those huge flips, and then also people who have met it super early?
Yes, you can. Yes, you can definitely see a list of who the students are, and you can.
I look at their individual.
Well, in terms of a learning curve, it's all because it's looking at correctness information. If you're looking at an individual student, it's always going to be 100% or 0, right? They're either going to get it right or wrong. So it's just going to go up and down and up and down.
Over time.
But over time, you should see it. Yeah, you should see it, jump up and down, and then they should get so many in a correct. So it'll go to 0, and hopefully that'll be.
But if I see them getting some of it right and others.
You could actually drill in and look at the individual problems that they're getting right and wrong and see, yeah. Yes, you can do that. I'll show you in a second. But here's that file that I opened, and it has some statistics in there, but it has like this problem hierarchy where it'll have the problem name and the step name. Right here are the step names, and if we go over to the far right, we can see there'll be a column of the KC model that I exported. In this case, it was that textbook model, and you can see that those steps are tagged with things like rectangle area composed by addition. Then you'll see it also automatically creates this new KC model name. So if I wanted to create a new model that I could say, you know, the WESST model, I could put that in there. And then I could retag everything here. It might actually be easier to take an existing column and paste it in, and then just change the name up here. So if I wanted to do something like merge rectangle area and square area, I could do that really quickly by saying, where's my find and replace them here? All right, someone help me. Where's my edit column? Huh? Oh, where at? Oh, here. Yep. So I could replace angle, I can spell it right. With, I can say. Okay, so it did 19 there. I'm not sure if that's right. Hopefully it is. And then I can also replace. So now, basically, I've taken all those out. And then I can save this. Then the text, we'll call it. All right, so that should be out there. And then I can come back here and do import. Choose the file. Where was that? Should be in here. And then I can click verify. It's going to upload that model. And it's going to say, oh, I left that column textbook in there. And it's going to say this already exists. It is also one that I don't own, so I can't change it. I could change the model name and bring it in there or skip it. I'm going to skip it. Alternatively, I could have deleted that column, but I highly recommend if you're doing this kind of analysis, you leave that column in there. So if you ever have to go back, you know which one it was and you have the actual data in there. So I'm going to skip that column. Then it's going to say, oh, we saw this new model, import WESST. If that's correct, I can click import. And it's going to go ahead and it's going to bring that new model in. And then it's going to go ahead and it's going to run the fitting parameters. It'll get queued up to run those. And then hopefully we'll see that in here and we'll see how this new merged model fits into this list of items. While it's doing that, I'm going to jump out back to the learning curve. And so from your question, if you're interested in, you can look at the particular students that are having problems and whether they got it correct or incorrect on that step. You can also find and drill down to specific students over here. So I could deselect all. And if I had a particular student I want to look at, I could go look at them or a group of students. I don't have enough time to do a lot of things that show you all the features in Datashop, but there's a lot of different things I can do. I can also create a sample, which would allow me to put any of the categories in there. So I could like choose the set of students, or if it's a, I wanted to look at a particular set of problems, I could do that as well. And you can save that, and then the analysis would only look at that sample that you have in there. Also allows you to export that sample. See if my KC model came in. All right, so it's currently queued. So it'll at some point it'll get in there and it'll run those numbers for us, and maybe we can look at that at my talk tomorrow if it doesn't get done here by now. Getting data out of Datashop, again, I mentioned was easy. You can click on export. And again, it defaults to the level of every single transaction out there. And you can see I can click on this export, and it'll just create a tab delimited text file that I can then import into R, SPSS, Excel, whatever you want to do. I can also export it by student step. So again, we have this concept to create the learning curves. We do the step roll up where we take all those individual transactions on a particular step. If there are multiple transactions, we roll that up, and you can do it there. So different analyses might prefer to use, it's telling me I didn't have any students selected. There we go. Might use the student step. Other analyses might use transactions. So depending on what you're doing, it's out there. Getting data in, there is a lot of information out here. Let's see if I can go up here under help. Screen is kind of. There's actually a lot of different information on how you can get your data set in. We have two ways of getting data in. You can either do it in a tab delimited format, or you can use a more advanced XML format. And the XML format allows you to do some more embedded kind of things if you had multi-values on some of the things that are harder to do in a text format table. You can use the XML. As if you have the data in the right format, it's gonna go in very easily, and it'll tell you. Let me see out here somewhere. We have here it actually is the format that we use and which ones are required and not required. So we need something like a student identifier. We have this session, the student session. If you don't have a particular session or all the data is in one session, you can make that whatever you want. You have to have a particular time zone. We have this concept of problem name. And then you need some things like step name, selection action for creating learning curves. So it'll tell you down here that these are the things you need to create learning curves. There's a bunch of other things you can have. You don't have to have KCs, and KC models can be applied on the import, but you can also create them like I showed you. You can create those after the fact as well. We also have this concept of custom fields. So anything, if you create a column and you just start it with the letter CF, it'll create a custom field for you. So if you have data that isn't in our format, but you want to keep it in there, you can put it in custom fields. And we have people who do that often for their own analyses because they want to share those custom fields with other people. So again, all that's out there. Datashop's been around for a long time. We have a lot of experience helping people get it in. So you can always email the Datashop help under contact us, and we can help you. Any questions, more questions on this?
You mentioned that LearnSphere also has Coursera data. Is it all the data or just selected courses?
So part of one of the components of LearnSphere is called Data Stage, which is Stanford's online course repository of data. I believe they have everything that Stanford has ever run on Coursera and edX. It's not necessarily the case that they can share all the data. So I've had pretty good luck getting subsets of certain data sets from them. Again, the Stanford folks who run DataStage are part of LearnSphere. So if you're really interested in that kind of data, you can email us or email them from the LearnSphere site. It's a good segue into LearnSphere. Candace Till is the person from Stanford who runs this, and you can contact her and she could help you with the data stage stuff and getting that kind of data. So on the LearnSphere side, we created this workflow tool that allows you to create and share analyses similar to those tools that we have in Datashop, like the learning curve tool. We had this issue with Datashop where people say, I really like your learning curve tool, but you're running this predictive model called additive factors model, AFM. It doesn't take into account, say, forgetting. And I really want something that takes into account forgetting. Could you add that? And we had this list of things that we always wanted to do, but didn't have the resources to do. So part of creating this workflow builder was to allow anyone to create and modify their own analyses. So I'm going to go ahead and log in here. And this is definitely a work in progress. This has been out in alpha kind of mode for about 9 months. So lots of things work. Occasionally things break. Hopefully nothing's happened that other things have broken. But I'm going to try and let's see, can I create a new workflow in here? Where's my... I'm going to create a new workflow, and I'll call it WESST. Public. All right, so I mentioned before we have this idea of import objects, analysis objects, and visualization objects. There's this other one called transform, which I didn't talk about, but it's simply a way to transform data. I would often argue that that should be in the import, but there were certain places where people wanted that otherwise. So I'm going to do an import. I'm going to pull in the student step because I'm going to generate learning curves. And I need to click on this little cog button there, and it's going to bring a list. This particular student step one, I can choose to do a tab delimited file, or I can use the data sets that are in Datashop that I have access to. One thing that is really, really cool about the LearnSphere project and the idea of sharing these analyses is everything that I'm going to go to is on GitHub. So you can see here, view on GitHub. So any of these analyses or imports, if you want to start and build your own, you can use something that already exists out there. So if you want to modify, say, the additive factors model, you could just simply do that by going out on GitHub, seeing the code. And I'll show you a little bit of that in a second. So let me choose a data file. Geometry. Usually this is bigger on a bigger screen, so you won't have to. So here's that one I was just looking at in Datashop. I'm going to bring it in here. All right, so now that file, I believe, is in here, and it's ready to go. Now I'm going to go into analyses, and again, this here is the Java code that's actually used in Datashop. So I'm going to pull that out. AFM is just a logistical regression. So there's also a version, I believe there's a R version of this out here. Maybe not. There's a Python version of AFM if you wanted to use that. But I'm going to connect these two together. And then I'm going to go down and pull out a visualization, which we have this learning curve one. Put that here. It's looking for student step as the incoming. So I can take the student step from here and bring it down there. All right, now I should be able to run this. I'm going to save it. And I went through that one. This one is running. And again, depending on the type of analysis you do, some can take a long time. You can actually set it up to email you when it's done if it's a super long one, and you can just go away and come back to it later. In this case, it's now been run. I can click on the results, and it's gonna, based on the AFM analysis, it has some output where it's gonna put out some of these parameters out there, like model values and the different student values. And I can also then look at the visualization of the learning curves, which we have. Oh, I was on a different model. I have to go back to that one. But it'll actually, if I selected the textbook model, I would get the same learning curves that were out there in Datashop. Click on this one, change the model. That was in the AFM analysis is where we would choose the model. I'm going to go down to textbook. So yeah, so this doesn't get me much. In fact, it actually gets me a little bit less because I don't have that interactive learning curve thing. But say, let's say I wanted to compare and look at another analysis. So you guys know Bayesian knowledge tracing? Anyone know what Bayesian knowledge tracing is? So that's a version of knowledge tracing or predicting knowledge that could be comparable to AFM. It's essentially a hidden Markov model that takes into account what the prediction of what the student knows with parameters for slip and guess. So the guess parameter is the student doesn't know a skill but gets it right. The slip parameter is a student gets a skill wrong but they actually knew it. And so I could actually pull this in, take the same data file, and choose my data model. Oops. The textbook one. Is that? And pull out another learning curve visualization here. That. So now this one's going to run, and this will allow me to look at the different parameters that get pulled out. And you can see, again, it shows you when it's running. It's going to go through and run the various algorithms. And again, I can look at the results. And now instead of just having the AFM, I also have the analysis for BKT. which I can look at the parameters that come out of there. Again, all of what the inputs and outputs for every object are out there under the GitHub thing. You can look at them. But I can look at the learning curve visualizations, which again, I switched to the right model on this one. So it should be exactly what we had in Datashop. And I can look at that same model, how it would be predicted with the Bayesian knowledge tracing one, which should be pretty close to the same, and largely is. I could compare those side by side or look at the values. But that's example now. Now this workflow is out there, it's public, you guys can run it, you can change the data set that it's using, you could change the data model. There are other analyses out there which people have shared. Our goal is, right now it's a little bit cluttered. We're going to start grouping things as people are building different types of analyses for different ones, but there's these public workflows out there. Are any of you familiar with the ALEX system? So that's a math system that's owned by McGraw-Hill. Yeah, we were working with those folks and they created a workflow. There's some, Ken Kadinger had a paper on the doer effect in MOOCs in online courses, whether watching videos versus doing activities does better. And you can see some different options where they did the doer effect on various courses. I can request access to those if I want them. And you can see other ones that are shareable and not shareable. But again, the idea is that these will go out there. People will be able to share. And if you were collaborating with someone, you could put your analysis out there. They could get access to it. Let me just go out and show you, if you click on any of these GitHub components, it's going to take you out to that particular component, but you can go up to the GitHub and look at all the components that are out there. You can also go to the LearnSphere hub out there, which will has a lot of workflow components as well as a template to build these components. We had a full-day workshop at the AI in Education and EDM conference that was just in Wuhan, China a month ago. I had Joseph put those slides out as well. Is that correct? So that was actually a tutorial on building a component for this. Gets much more in depth and gets into the coding. But if that's something you guys think you want to do, that's out there and available. Yeah, so that's pretty much LearnSphere and Datashop, and again, they're kind of intermingled and due to the history of them. But LearnSphere is kind of this idea of a umbrella organization for people to bring in all these different repositories. Datashop is one of those repository. Discourse DB is another one, which Carolyn Rose is going to talk about, and she'll mention that in part of her talk in the CSCL work that she does. There's also MOOCDB, which if you're interested in that, you can Google that with MIT, and that'll take you out there. You can always reach out to LearnSphere, myself, or the MIT folks will be happy to tell you more about MOOCDB. Any questions, comments? You guys think you can use this? Let me, I'll show you one other thing that's out there, which I've been talking about less and less as it's getting farther into the future. You guys familiar with the KDD workshop, KDD conference? Every year they hold a KDD Cup. Datashop actually held the KDD Cup in 2010. The website is still out there, and you can still get the data out there for the competition. The site's running, you can actually still submit. So I still have people yearly who use the KDD Cup in their course that they're teaching and have the students have their students do something. But a lot of people have used this these data sets for other education work and papers. These data sets have been used in a lot. There's also several workshops that we ran, which you can go out and read papers that people submitted. Some of the winners of the KDD Cup submitted their papers and the analysis that they used. Let's see, I always like to go out and we can see the last time someone submitted to the leaderboard here. So yeah, on July 8th was the last time someone submitted of this year, but you can see a bunch of people. This again was probably done in someone's course that they someone probably had them use this. But it's this is another great resource for educational data mining. The data sets in here are much bigger than the ones that we had in Datashop. These data sets represent an entire year of learning from the Carnegie Learning Intelligent Tutors for Algebra.
Can I just borrow 1 minute tutorial to show people how they can access this stuff later?
Yeah.
So basically, you know, you got a big overview, and now, well, 2 months now you forget all this and suddenly think, oh, I want to check this out, right? So one of the student volunteers kindly put together a doc. It's now linked from the WESST website, where for all the tutorials, as we go along, we're going to try and add in. So just go to this URL, and it's just a Google Doc where for each of these, we're going to kind of add different links. So for example, if you don't mind me, John, I'll just jump and what is the GitHub repository?
Just type over top it. I don't know.
Okay. But let's pretend this out. Okay.
Yeah.
So for example, you know, I'll ask John and others, and anyone is welcome to kind of add in things that they find useful to sort of put links like these. So you can come back to this later on. It'll have like a guide. We'll add the links you sent. We'll add some extra slides so you can actually follow up on this later. Cool. And John, can I ask you maybe to say a bit about how do you apply this to learning management system data? Because a lot of the data that we have on campus, what does ideally stand for?
Integrated virtual learning.
So integrated virtual learning environment, great. Ideally is what they use, and it's been running for like 8 years.
Yeah. So
yeah, how would they use this?
So as long as you're collecting and can export data out of that in a transaction format, you could get it into Datashop. You could use it. You could use Datashop as a mechanism to share amongst your colleagues the particular data set you want. For the transactions that actually are showing learning, so I don't know if people do quizzes and other types of activities in the learning management system, those could be coded with knowledge components, so you could actually create learning curves from that data. Again, you can bring in all the data and use it to share, and then only worry about the ones that are learning opportunities to do the learning curve analysis. You could, however you're exporting the file now, you can actually bring that into LearnSphere, create a component for an import. You could create your own analyses that you might already have. You might be doing stuff in R or other statistical packages. You could build a component that wraps that up, share that with your colleagues as well, share it with the faculty. Yeah, so those would be different ways you could get started. Yeah, you can, from the LearnSphere, you could do any kind of analyses, and there's other ones out there. Again, my work is mostly around the learning curves and stuff, and that's what I feel comfortable. But there's some in that doer effect one. They actually built a component that was looking at video watching in an online course. So you could take that as a starting point and drill down and look and see what they're doing. That might be an analysis. Yeah.
Sorry, I just wanted to ask. You had given some examples of intelligent tutoring systems whereby you started seeing jumps at the back.
Yep.
Just wanted to ask whether or not you have a model for kind of deciding what to red flag, what kind of jumps to kind of red flag beyond certain, what are acceptable kind of learning curves? Is it more a kind of a judgment call that we have to make, or is there something to kind of say, okay, that looks like an outlier? Is this something that we want to look at? Do you have something inside the system that actually does?
So we have that categorization that automatically does it based on some numbers out there that we put in that we consider good numbers that generally work, but it's really going to be domain specific as well as the what produced the content. So, I could have 2 geometry area data sets that came from different systems, and not only could their KC model, the best fitting KC model, be very different, but the type of data and the type of learning curves that those systems produce could be quite different too, just based on the interactions that students are doing. Yeah, so that's probably an active area of research that someone could do some more automated stuff in. Right now, when we're doing our automated stuff, we do make those judgment calls, and we have parameters that we make the splits and things on and make these judgments on. Usually it's by looking and saying, oh, we need to make sure there's at least 10 students at that opportunity, or we don't care about it. Yeah, hopefully.
I mean, just as a follow-up question.
Yeah.
It seems seems that a lot of this improvement of your learning curves comes about by greater decomposition, right, of the cases, right? That's something that you guys look into. Are there examples of keeping the same cases and having some kind of intervention that you just do, for example, longitudinally with different groups of people, perhaps, so to kind of say, okay, that's using the same cases, that's kind of improvement. Is that something?
Oh, absolutely, yeah, and I think that's actually a more straightforward use that many people have done in here before, and there are lots of data sets where you'll have experimental conditions. If you look in the data set where they're doing some A/B testing with different interventions and seeing what works, what doesn't work. Yep. Other questions?
So in the US for the education research, can you use this data, put it on the LearnSphere or Datashop for any study, or you do need to seek additional permissions for students to utilize the data in a specific way?
Yeah, so it's a little bit different between LearnSphere and Datashop. In Datashop, everything has to be anonymized or de-identified at the student level. And when you import a data set, it will not be shareable until the Datashop manager verifies that A, you have permission to share that data, which in the US, that typically requires you to show IRB if it's collected from a study, if it's collected from just daily interactions. There's some different rules around how you can share it, but we kind of verify that the data can't be de-identified, and then it goes through that process. For international, we'll work with you closely to see what are your rules and what you have to do to make it shareable. With LearnSphere, the analyses and the data access are kind of split. So you can actually have your data sets not stored in LearnSphere. You could just have them be text files that you upload when you're running your particular analysis. So it's a little bit different that way. There's less strict rules about what we can do in LearnSphere. That makes sense. If you have a specific example or specific data that you want to talk about, I can be more specific. All right, well, thank you. Let me just again, on the contact us on Datashop is this Datashop help, which can work for both LearnSphere and Datashop, and has quick turnaround. I have a great staff who helps me look good and does all the debugging and programming stuff for me. So, all right, thank you guys.